Today we're going to talk about how to install multiple steppers for the Z-axis. Now I need to take you through a couple of things to explain the hardware and the software because I discovered some issues compared to other boards that you're going to need to address. So first of all, we have our steppers here. So they're enumerated from 0 all the way up to 7. Normally 0 will be the X stepper, then Y stepper, then Z stepper, and then of course you have your extruders that are 0 through 5. Now over here you have two connectors for your Z axis. So there's a Z1 and Z2 essentially that will work off of one stepper. Now if you need to add two steppers in addition to this, then they're going to be out in this direction. Now on other boards, it used to be that you would skip the first extruder. On this one, it's changed around a bit, so I'll walk you through it as we go. But I'm going to actually use the steppers for the TMC 2225s. They're almost exactly the same as the TMC 2208s, except there might be a different stepper board chipset underneath. But that detail is not important, but you will need to know that you'll probably need to have cooling fins on all of them when running them in a printer, and also have a cooling fan on them for safety so they don't overheat and burn up. So what we need to first figure out is the actual configuration, because this is going to be TMC 2225, which is obviously the same as a TMC 2208. So we're going to have to set the jumpers for UART the exact same way. So I'll show you how to do that, and I'll also show you what the issues were. So I'm going to show you first where the actual motor steppers are. So of course I was talking about how it's motor stepper 0 all the way through 7. So in this case, we're going to be using motor 2, and you can see there's a 1 and a 2 here. But we're also going to be using motor 3, and then we're going to use motor 6. Now I know that's profoundly different from what you're used to seeing when I do this, but in this case, either one of two things happened. Either Marlin provided the information incorrectly in their configuration file, or Big Tree Tech did. I don't know which. At the moment, I don't want to research that part. I just want to show you how to set it up. So what we're going to do is, obviously from the manual, figure out where UART is for the actual setup. So we're going to do that first. So I'm going to go over to the board and we'll set that up first. So in this case, on the board, the first thing I want to do is actually put these jumpers in for the fourth one over, which would be the second stepper for your Z-axis. So I'm going to jump the two pins right down in here so that we don't have to worry about these two. Now technically I've run it both ways, so you don't really need to put the jumper in, but I'm trying to show you good habits. Of course I can't get the second jumper cap in very easy, so we'll try it that way. So what I'm going to have to do now is actually pop out these caps down here. So as you can see, I'm using a dental pick because it's easier for me. Takes a little bit of work to get these out because they have them and they're really tight. So that's the first one. So this is number 2. We have to do number 3, and we have to do number 6, I believe. So I'm going to pop out the second one here, which would normally be your first extruder. If in fact it's an issue with Marlin, you can always fix it in the pinout file. But at this point, I just want to show you how to do it, and I'll show you how to configure it. And if you want to change the pinout file to align these differently, you can. So these are kind of hard to get out because they wedged them in there so tight. So now that we have them out, we're going to put the jumpers for UART in position. And here's the last one. Fortunately, I got to switch hands here. There you go. So those are all set. Next thing you need to know is the actual colors on the side match up to how you're going to install it. So here's the first one. Then we're going to do the next one, which will be obviously colored correctly as well. And then we'll do the last 2225. So that's going to go right over here, pardon me. So now that we got that configured, we're going to connect the steppers. So I'm going to try and align the colors to be exactly the same. So as you can see, they have to line up color-wise correctly. So I'm going to slide these down so that I can make this look neat. I know this is hard to see as is, so. And then we'll take the last one and put it in here. So we're all good there. Now we have to actually set up the power. So as you can see down here, we have motor power that we're going to run our PSU off of over here. So I marked red for voltage and unmarked for ground. And then I have red for voltage for the board power and then ground. So to connect this, what we're going to do is we're going to slide these in and we're just going to tighten them down. Then I'll slide in the other one. Get that nice and tight. Now I'll do the same over here. And in earlier tutorials, I did accidentally get these backwards, so I remarked them. But if you can check under the board, you can get the right color, and that was for the actual heat bed. Now in normal cases, the heat bed doesn't matter. The only abnormal case would be if you're using a relay to drive other power from it. But for now, we're not going to talk about that. So now that we got that set up, we're going to have to actually load the firmware. So I'm going to open this up and I'm going to place the SD card inside of here. So once that's in there, I'm going to place it in the computer. You may hear a beep. Now I'm going to actually go over to the computer and I'm going to pull up VScode. Now I've already pulled up the firmware, so let me minimize this for a second so you can see. The current firmware I'm working with is 2.0.9.1. Now that is subject to change. Unfortunately, I have no control over that. That's a Marlin issue. So I'm going to click on the Explorer, then open folder, my downloads folder. Now I've already downloaded and extracted it. So the first Marlin folder, the second Marlin folder, then select folder. So once that's selected, it comes up first of all with the platform io.ini. Obviously it's set for the Mega 2560, which is their default configuration for the ramps 1.4. We're not using that, so I'll show you how to figure it out while we go. So in the Marlin folder, I'm going to go to source, core, boards.h. Inside boards.h, I'm going to search on Octopus. And if I spell it correctly, it should come up. And as you can see, there's two boards. This is the one you want, version 1.1. So I'm going to copy that because that's what we're working with. Close out of boards.h. But before I do, let's note the actual chipset we're using. In this case, it's not the 2560. It is actually the STM32F4. That's going to be relevant in just a moment. So let's close out of here. I'm going to minimize core and source, and I'm going to go to configuration.h and search for motherboard. Inside here, I'm going to highlight the ramps board and paste our board over it. Next, I'm going to change the serial port to -1. Now I'm going to search on A4988, which will bring us to the steppers. Now, as you can see, the steppers right now are already uncommented for the ones that normally would be used. In this case, though, we're using a TMC2225, so we're going to use the TMC2208 as our substitute for that. So I'm going to paste it there. Now, the other steppers for Z, as you can see right here, for Z1 and Z2 need to have the comments removed. So I'm going to do // and then // again. Then I'll paste the TMC2208 over the A4988, and we're all set there. Now, we may have to configure this depending upon the precision that you want to step at, but I'm going to actually skip over this step because I covered it so many times that if you watch my other tutorials, I'll actually explain this. So, let's go to Configuration Advanced. First thing we need to search on is 800, and it may take a couple of searches, and this will bring us to our actual steppers. So as you can see right here, it's the one that we're working with, and here's the micro steps. So if you want, there is a way to chain these together, which they talk about up here. So I'm not going to cover that. I'll let you read it for yourself. So now that we have that set, and we know we're going to be working with these two as well, they should be all the same. So you can see that they're using the variable from here to carry to here. So anything you change here will be translated to here. So what the thing was that I didn't want to talk about because I've covered it so many times, I'll show you real quick. So over here, if you change for your your Z-axis 400 to 800, or doubling the precision, then over here you're going to have to change this to 32. Once you do that, it will be carried forward with the variable name up here to the other ones. So we're only using 3 of the 4 possible that we could use. So what I'm going to do now is I'm going to search on TMC_debug so that we can enable debugging. So it's monitor driver status. I'm going to remove the comment with a // in this case. Then I'm going to do it a second time when I find the other one, which is down here, and this is for the debug command. So // again. And now we can use the M122 command. Now that we have that set, we have to set up the actual dual steppers. So we're going to search on dual _stepper, and that'll bring us to the grouping of what we want to work with. Now down here you can see that we have our number of Z stepper drivers. In this case we're using 3. So we're going to put a 3 there. Now, the issue that I talked about earlier with it being in the wrong order is actually under source, pins, the chipset type, which is STM32F. And then if you go in here to the common, you'll see that these pins are associated with the pinout diagram for the board. Now, they might be out of order, or the board might be drawn in such a way that they have them ordered different. I don't know. I don't want to research this part, but I'm showing you the way to do it for 3 steppers right now. So now that we've got that sorted out, there are other settings in the advanced configuration that we can set. If you want to change or invert directions, they have the option here. And of course, you have other options for end stops. I'm not going to cover that at the moment. It's kind of intuitive. So what I'm going to do now is show you actually how to build this. So we have to go back over to the platform.io.ini, and we have to get the default environment correct. So that means going over to the ini folder, finding our chipset, which is STM32F, and then searching in here for Octopus. And hopefully it'll come up if I'm in the right folder, STM32F. And I spell octopus correct again. And so what we'll do is we'll copy this environment right here, which is bigtree underscore octopus underscore V1. Now we'll go back over to platform.io.ini. We'll paste it right here. And then what we'll do is we'll do a clean, because there's a previous build that comes with your download for the Mega 2560 chipset. So we'll get that out of there by clicking on this clean button, which is a garbage can. So that should be gone from the folder. Now we'll click the checkbox. Once we do this, it'll take care of multiple builds or compiles. Now, if it doesn't work the first time, like it appears to be in this case, what you need to do is probably click it a second time, and then it will work in theory, unless there's something wrong. If it doesn't work the second time, find the very first error that you encounter and correct it, because the errors thereafter from the first error, which would be in red, are usually related to a cascade of errors that may be related to it. So, while this is building, we can check on the progress by going over to the build folder, and inside here you can see it's going to be slowly building out. We'll see our firmware.bin in here in just a moment. So as soon as this finishes, we'll see firmware.bin. We can right click on that and then say reveal in File Explorer. Inside File Explorer, what we can do now is we can actually right click on this and send it to our USB drive, which is over here. And as you can see, it's got a firmware that we just recently loaded. So I'm going to click back, I'm going to right click, and I'm going to send it to the USB drive. Now, once that's complete, as you can see, we have firmware.bin and firmware.cur. Now, firmware.cur used to be firmware.bin, but after it loads, it renames to firmware.cur to prevent it from reloading every time you boot up. So, what we're going to do next is go back over to the workbench. We're going to pop out the drive. We're then going to plug the SD drive into here. And I want to show you something. I discovered that you don't actually need these. So I'm going to pop these out. They'll actually cause an error if they're connected, because I had some issues with the initial ending of this where I had to re-record it because those were in there. So I'm going to plug this in and show you that the firmware will load on 5 volts because of this jumper. So as you can see, it's flashing right now, which means that the firmware is loading. Now that you've heard a beep on the computer, it's all set. So I'm going to remove this, pop this out so we can run off direct power, plug this in, and now the USB will not work until it's finally plugged in. So I'm going to plug this in. Then what I'm going to do is I'm actually going to go over to Pronterface, and we're going to try this out. So inside Pronterface, as you can see, it says COM port 1, which is probably not our COM port because that's default to the computer. So what we need to do is locate it. So I'm going to go to the desktop for a second. I'm going to type Device Manager, bring that up, and then check to see what it is. In this case, it's COM port 9. Now there's 2 ways to change it. If it shows up over here, you're all good. Otherwise, you can highlight this and change it yourself. So we're going to try and connect. It looks like it's connecting. The printer is now online. So next what we'll do is we'll do M122 and press enter. And this will help us check to see if there's any issues with the steppers, but they say okay. So what we're going to do is we're going to go over to Pronterface so you can see it better here. And I'm going to move the Z-axis and see what happens. So as you can see, it's a little bit of a stutter step. The reason for that probably is a loose cable over here. So let's try that again. Yep. So when the cable's loose, you'll see a little bit of a stutter step. If you like my tutorial, please press the like button and subscribe. And once again, thank you to the patrons as well as the people tipping on PayPal. It's greatly appreciated and helps offset the cost of doing these tutorials. So everyone take care, wear a mask, get vaccinated, and be safe.